So the second part of the quiz that you were responsible for working through was using the molarity equation and stoichiometry to calculate the molarity or volume of a neutralization reaction. So there's a couple of things that I want to touch up on before we kind of like jump into that. The first thing I want to touch upon is, how do you know if you're given a chemical equation that one of the reactants is a base? What are you looking for? OH, for sure. So if you have a base, right, you should be looking for the polyatomic ion hydroxide. If you're trying to identify if an acid is present, you're usually going to be looking for, in the scope of this class, hydrogen at the front of the formula. Okay. So with that in mind, this tells me that the base that I'm going to be working with here is NaOH. And we're asked to calculate the molarity of NaOH if the volume of NaOH is 0.0250 liters. That also tells me, or that, knowing about acids and bases tells me that I have some information about the acid H2SO4, which happens to be sulfuric acid. So those are our parts. So the first thing that you have to do in this process, which is a 3-step process, is you have to calculate, because you've been given the most information about your acid, you're going to calculate moles of acid. So step 1 is to calculate moles of acid. And so we're going to do that using the molarity equation, which is up above there, right? So molarity, we're identifying our variables, moles, and then volume, in this case, is liters. In this problem here, we are told that we have 0.0116 liters of our acid, and we are also told that we have a concentration or a molarity of 3.00 molar. So when I go to set this problem up, I'm going to use my molarity formula, which is molarity is equal to moles over liters. And so when I substitute my values in, I have something like 3.00 molar equals moles over the 0.0116 liters. And just like we did yesterday and the last week, we are going to solve for moles by multiplying both sides by 0.0116. So 0.0116 liters times the 3.00 molar gives me moles in this case. And when I calculate that out, I get the 0.0116 times 3, which gives me a value of 0.0348 moles of acid, which in this case is H2SO4. So that's our first step. Our first step is to calculate moles of acid. And so we did that, and we got our answer right here. Our second step is to convert moles of acid to moles of base. So step number 2 is convert moles of acid to moles of base. And we're going to do that with a stoichiometry calculation. And so it's simply going to be mole to mole, but I'm going to take my calculated value, which is 0.0384 moles of acid, which in this case is H2SO4. I'm going to put that over 1, and I need to figure out what my mole ratio is. So mole ratio would be, so I'm going to go up top here and figure that out. So in this case here, I go back to my balanced chemical equation, and I see that I have 1 mole of H2SO4 present for every 2 moles of NaOH present. So that tells me that I have 1 mole of H2SO4 for every 2 moles of NaOH. So I'm going to set the mole ratio up so that moles of acid or H2SO4 cancel out. So I'm going to put 2 moles of NaOH on the bottom, or on the top rather, and 1 mole of H2SO4 on the bottom. Did you have a question? Okay. All right. Yeah. So when you're doing the problem, you don't have to write down the mole ratio or report it. I'm just doing it because I just want to make sure everybody knows where I'm getting my stuff from. Yes, sir.
Is it 0.03884?
48. Good catch. Good catch. Good catch. That would definitely change my answer. 48. Okay. So I'm going to take the 0.0348 times 2, eventually divided by 4, and that will give me 0.0696 moles of NaOH. So that's my second answer in this problem. And then the third step here, our third step for finishing this problem up, is going to be calculate the molarity of the base. So that is a molarity style problem. So that's going to be molarity is equal to moles divided by liters. Okay. So in this problem, we just calculated the number of moles. So that's going to be 0.0696 moles. And the math problem itself gave us the number of liters to be 0.0250 liters. So our formula says molarity is equal to moles over liters. So we're solving for the molarity of the base this time. So we're going to take that number of moles, which is 0.0696 moles, and we're going to divide that by the volume, which is 0.0250 liters. And so when I solve this, I take 0.0696 divided by 0.0250. That is not what I wanted to do. 0.696. Wait. Yeah, 0.0. I don't know what I typed in here. 0.06696 divided by 0.0250. That makes more sense. Holy mackerel. My molarity with sig figs here would be 2.78 molar, and that would be NaOH for my final answer. Yes. Yes. So that's how we would solve this style problem, where you're asked to calculate the molarity or volume of a neutralization reaction. You have to be able to go through all of the steps when solving this type of a problem. And there's going to be 3. Okay.